Hello everyone, can you hear me clearly? All of you?
Yes, sir.
Yes,
Great.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Awesome.
Yes, sir.
So today we will be doing something really exciting, hopefully. Ah, now it's fine, I guess. Yeah. All right. So let's wait for a few moments to let a few others join. Uh, we will be working with geometry today. Now, this particular session is designed for um, the Maths Olympiad, Bose Maths Olympiad coming up, the Winter Bose Maths Olympiad coming up on 1st of November. This is the first training session for this. This particular session is designed for students from class 5, 6, 7, and 8. Now, if you are not in 5, 6, 7, and 8, you can still stay in this session, but maybe you'll find some of the stuff a little bit more easier. Uh, you can join in the other session, which is the one in the coming up at 8 p.m. That one is actually for seniors, for students of yeah. So that's the main preface, I should say. Anyway, just a second. Okay, maybe I can just do this. Okay, so this is better, I think. Yeah. All right, so we will be discussing, um, we'll be starting with geometry today. Geometry, a specific part of geometry, rather. And the main idea of geometry that we will be using, there are several viewpoints in geometry that one can use. The one that we will be using involves something called transformation. So I'll explain to you what I mean by that, but first let me write that. So we want to start with something called transformation, and this is quite different from traditionally the way we understand geometry in school or other places. And I'll explain to you how it is different and why I find this more exciting than the traditional forms of geometry. So this is why it is how it is different. We can think about traditional geometry as something that's static, that does not move or change. For example, if someone asks you in traditional geometry what is circle, you would probably draw a picture like this, and you would say that, okay, take a point O, take a point O, and the circle is basically the collection of all the points which are equidistant from O, of course on the plane. Collection of all the points which are equidistant from the center, from a point, and you will say, and the person, of course, your friend will understand what you're saying. You'll be right. But in transformation geometry, you will say this and you will think about a circle in a completely different way. You will get the same end result, but you will think about it in a different way, and that matters. So how will you think about it? Well, you will say, okay, let's take O to be a fixed point, and let's think about P as a moving point, and circle is the path traced out by this moving point as it moves. Okay, some other people are trying to join. Okay, as it moves on the plane, such that the distance OP is always constant. So the thought process is a lot more dynamic. You are not thinking of this as a collection of points. Instead of that, you are thinking of it as a path traced out by a moving point. In your mind, in your imagination, there is a lot of movement when you think about transformation geometry. The simplest forms of transformation that we all know about are translation, and we will be talking a little bit about that today. So let me erase this picture and go to a problem. So the first type of transformation, and we will learn quite a few, and in the geometry module at Chinta Maths Olympiad program, many of you have learned more of these. So the first one that we will learn about, this is called translation. And the idea of translation is so easy, Spondon, that you will be able to, and everyone will be able to understand it very quickly. The idea of translation is this. It's parallel shift. The idea of translation is parallel shift. What does that mean? Well, suppose this is an object. Let's call this object A. Suppose you are pushing this object in a certain direction, maybe in this direction, and you are pushing it by 5 centimeters. So the final position of the object A, maybe I can draw this in green, is here. Let's call this A prime. That's the final position of this object A. So we are learning transformation geometry for Maths Olympiad, those who have joined a little bit late. And we will be using techniques of transformation geometry to solve beautiful problems. And this is one of the first type of transformation that we will learn. It's very, very easy. It's called translation. What is translation? It's simply parallel shift. It's parallel shift. So if you have an object, let's call that object A. If you have an object A, then you say, okay, you want to move this object in a particular direction, and you want to move it by that distance. So two things you have to mention: direction and distance. How much you want to move, how much you want to move, and which direction you want to move. How much you want to move and in which direction you want to move. And you can tell the final position of the object. So let me put it down here like this. In transformation geometry, in geometric transformation, the input is the initial position, and output is the final position of an object. So geometric transformation, the notion of geometric transformation, you can think of it like a machine. You can think of it like a machine. And what does this machine do? It takes in the input position, the initial position of the object, and it gives out the final position, the place where the object is going. It's that simple. Okay? All right. So let's start by using this notion of translation, and let's use it for a particular problem. It's a very beautiful problem. Many of you have seen this problem before. So let me put this problem in the board. Maybe I can use a different board here. So here is the problem. I first time found this problem in a book by Yaglom. I'll just give the name of the book here so that you can find it somewhere in the internet, in the beautiful world of internet. Yaglom was one of the greatest mathematicians who wrote for extensively for kids like you, and a lot of Olympiad-based geometry is from his book. So this is one of the books by Yaglom, and this particular problem has come in many Olympiads. So idea is this: that suppose you have a river. Suppose you have a river like this, and you have your home here. Can all of you see the board? Can all of you see the board? Okay.
Yes.
Okay, great.
Yes,
So
sir.
one of you is unable to see, I think. Okay. So this is the home, and this is your friend's home. This is your home, and this is your friend's home. So you want to go from your home to your friend's home, and you want to make a bridge on this river so that you can do that. The bridge will be a vertical line across the river. The bridge will be a vertical line across the river. So, for example, we could have the bridge here. Maybe I can draw this in black. So maybe this is the bridge. You can have the bridge in this particular position. Maybe you can have the bridge here. Then you can go from here to here, take the bridge, and then go to your friend's house. Do all of you understand that there can be a variety of places where you can actually construct the bridge? The bridge needs to be perpendicular to the river. So it needs to be like this. It cannot be a slanted bridge. That's the condition of the problem. So there is a variety of places where you can actually draw the bridge. Do all of you see that there can be many places, infinitely many places, where you can actually construct the bridge? Okay, so now that we are good on that, the question is, what is the optimal position of the bridge? Where should we construct the bridge such that the distance traveled is minimum? So here is the question. I'll write it down. Here is the question. Where should we construct the bridge? And our objective is to minimize the distance traveled. Our objective is to minimize the distance traveled. That's what we want to do. That's what we want to do. So I will clear up a little bit of this. I will. So you can, if you have an idea, you can send it to me in private chat. Okay. So those who have joined a little bit late, let me explain what we are doing here. This is the Bose Maths Olympiad training camp, first one, intermediate training camp for class 5, 6, 7, and 8. This is a session on transformation geometry for Maths Olympiad. And we are learning a very simple type of geometric transformation called translation. Now, those who are taking classes with us, all of you know that the only way to learn a concept is to do a problem which uses that concept. So this is the problem that we are doing to understand what is translation. Translation is a geometric transformation, and we will be using that transformation to solve this particular problem. It's a very beautiful problem, and I think all of you can do it. Give it a try, all of you. So Shouradip is saying that join the home. Oops, sorry. Join your home and friend's home by a straight line. We can't really do that because, of course, you understand why we can't do that. Because it's
Sir,
okay. It will intersect at 2 points. Yes, indeed, they will intersect here and here. Let me change the color a little bit. Maybe A and B. This is H and this is F. Okay.
sir, can I tell? Sir, can I tell?
Yeah, please go ahead. Go
Sir,
ahead.
so you have to find the midpoint of AB, and then that will be the midpoint of the bridge.
Midpoint of AB, and that would be the midpoint of the bridge. Okay. Okay, Arav, what is your idea? So all of you understand what Shorodip is saying. He's saying, okay, take the midpoint of the bridge like this, and then this is the shortest one.
Yes, sir.
You see, whatever we say must be backed up by reason. We cannot. So you have to now give me a reason why this particular path will be shorter than all other possible positions of bridges. Maybe this is correct. Maybe this is correct. But you have to think about it, why this will be correct in the first place. Okay, Strinja joined a little bit late. So those who have joined a little bit late, I will explain a little bit of the problem one more time. We are using a geometric transformation called translation to solve this problem, which basically says that there is a river, and on one side of the river, I have my home. On one side of the river, I have my home, and on other side of the river, there is my friend's home. And I want to build a bridge that is vertical, across the river. The question is, where should we construct the bridge?
Sir, I have an answer.
Okay, someone has an answer. Go ahead. Who is it? What is your name?
If we consider the river to be two parallel lines,
Wait, who is speaking? Can you tell me your name?
Sir, Aryadeep.
Arjudip. Okay, go ahead, Arjudip. Go ahead.
Sir, if we consider the river to be two parallel lines, then
Yeah, these are
if
parallel
and
lines. Yeah.
my home and my friend's home to be 2 points,
Right.
then the line joining the points is the shortest. But as it is diagonal, in the question it is said we should give a vertical line in the bridge. So so as it is the hypotenuse in a right angle triangle, the perpendicular will be the shortest.
Okay, so can you tell me how? So using the points H and F, can you tell me how should I draw it? Maybe you are right. Using H and F, can you tell me how to construct this?
Sir, we can first draw the line connecting them.
Okay, let's connect the line, join the line points H and F like this. Okay.
Yes, sir, and then from H, the first line of the river, the upper line.
Okay, so
The line
X,
intersects
Y
with
maybe.
the point. Yes, in line X, Y.
Okay, so this is.
Yes, sir. And if we drop a perpendicular from A.
Okay.
And join.
Let's suppose this is B. Okay.
Yes, B and F. And if you join B and F, it will be the shortest point because the perpendicular line will be the shortest.
Well, but the perpendicular will be the same, considering the reverse length is two banks of the rivers are always parallel. If you sort of suppose that, because this is Mn, so wherever I draw the bridge, it will be the same length. It will be the same length. So I will, okay, I really like your approach. So if I draw another bridge here, let's say A1, B1, can you show that HA1, B1, F will be longer than HABF? Do you understand what I'm saying? To show that this is the shortest path, what I did is I took another position of the bridge, arbitrary position of the bridge. Okay, suppose that's A1, B1.
Sir, because the straight line joining two points is the shortest, and that from that point the perpendicular line is always the shortest.
Oh. Okay. Maybe you have
Sir,
to. Yeah, go ahead. Go ahead. I think
so
I really like it. Go ahead.
So the bridge will always be the same size.
Bridge will always be the same.
But h to the point in xy and f to the point in mn will change
Right.
after it becomes perpendicular. Like HA to the mn1 becomes one line, including the bridge. After that, it will increase.
So, for example, in this particular picture, I can sort of see that HA1 is shorter than HA.
Yes, sir. And
But
this is longer.
FB1 is longer than FB. Right? Isn't it? It sort of looks like that. FB1 looks longer than FB. Isn't it? So one
Yes,
of the parts is smaller than that path, and the other part is larger than that path. So yeah, so we have to sort of see that. So maybe a little bit of more thinking is necessary here. Can all of you think a little bit more?
So I have an idea.
Okay, go ahead.
So if we draw
Can you first tell
from
me your name? So whoever speaks, can you tell me your name first so that I understand who is speaking?
So Aniruddha.
Aniruddha. Okay, go ahead, Aniruddha. Go ahead.
So if you draw perpendicular from H to MN, and then from that place we draw a line to F.
One moment. Let me clean this up a little bit. Okay, so this is okay. Let's clear this up. All right. So Aniruddha has an idea. So H2. Where should I put a perpendicular? Sorry.
MN.
Let's do that. Suppose this point is R. Then what? You see how beautiful this is. We have this river. It's like Howrah and Calcutta and the Howrah Bridge. You need to know that this is actually a very real problem. If you have the Howrah station and the Shialda station, these are the two of the most busiest railway stations of India. Not only India, probably Asia. And you have the Hooghly River sort of flowing between them. And someone needed to solve this problem using some amount of mathematics to place the Howrah Bridge in a position that would reduce the transportation time for hundreds of years. So it's a really good problem. It's a real problem. And this can be solved using a very simple notion of geometric transformation, which is translation. And all of you today can solve this. Just you have to think a little bit harder. And Aniruddha has an idea that from the point H, drop a perpendicular on Mn and call the feet of the perpendicular R maybe. What happens next? Anyone?
To draw a straight line from R to S.
Draw a straight line from
R to S.
R to F. Okay. What happens then after you draw a straight line from R to F? Is this the position where you should be drawing the?
Sir, you have to draw another perpendicular from XY to F.
Okay, maybe let's draw that.
So we should draw a line parallel to RS.
Sir, and then from S to R, you have to draw a line, and then the midpoint there is the midpoint of the bridge.
Okay, this is a fancy solution. Maybe this is right, but why? It's good. Everybody should give their idea. You know, in Russia, they used to have this mathematical circles where no one actually would give the solution. No teacher would give the solution. Students would usually discuss and come up with the solution themselves. This is one of the greatest experiments in mathematical education in the history of the world, and some wonderful mathematicians came out of that process, like Gregory Perelman, who solved the Poincare conjecture. You can Google him. It's one of the most interesting mathematicians alive. Anyway, coming back to this one, someone says that HABF is the answer, is the solution. Is it the solution?
Yes, sir.
If it is, if I put another line here, can you show that HA prime B prime F is longer than this one? HA prime B prime F is longer than this one, where A prime B prime is another arbitrary position of the bridge. Okay, I'll give you a hint so that you can sort of accelerate the way you are thinking. Imagine translating the MN bank, push the bank to XY. Imagine translating the MN bank to XY. Think about it.
Sir, hello?
Okay, just
Sir, I'm from there.
okay, just think about it. I'll let you say what you're thinking, but think about it. This particular distance, the length of the bridge, that is the least interesting thing when it is on the river. It is the least interesting thing when it is on the river because it's the same everywhere. So this is the amount of just okay, give me I'll let you say what you're saying. Give me a second. Let me complete the sentence. This is the translation that we will be using from A prime to B prime. This is the translation that we will be using And the clue is that you can do this translation instead of on the river anytime you want. Think about it. Instead of
Sir,
doing, just a
if
second,
you shift,
instead of doing this translation on the river, try doing this translation a little bit ahead of time. Now you can tell me who is speaking. Tell me your
Sir,
name and
sir,
then.
if we translate the bank Mn to xy,
Okay.
and then we draw a straight line connecting H and F,
Okay.
then the straight line will intersect. Mn has already is coinciding with x and y, xy. If we translate Mn to xy,
Right.
yes, sir. And when we
But
draw the
wait, if
straight
you
line,
translate
it will
m
intersect.
into xy, f is also moving. H is also moving, isn't it?
Yes, sir.
Think about it, everyone. You cannot just move one thing. Everything is sort of moving. You can fix xy. Think about it as everything is moving.
sir,
Hello, sir.
you can move M, N, and F together above, connecting M N to XY, so that it becomes one line.
Okay.
And then you draw a line from H to F, and then you again expand the river and make a perpendicular line between the two, between the line HF.
Okay, you're almost there. You're almost there.
Sir.
Yeah, someone else. Go ahead.
Yes, I am Shaurodeep.
Okay, Shaurodeep. Is this the same Shaurodeep
if it-
whom I know?
Yes, yes.
Okay, go ahead, Shaurodeep.
Sir, if we translate the line Mn to xy, then only one line will be left as a river, and the point F will move up to some distance, say B. That
Okay,
distance is equal to the distance of the bridge.
excellent. Let's do that. Let's
Uh,
see. One moment, Shaurodeep. You have a very good idea. Let's do exactly what Shaurodeep is saying. So let me draw a thin river so that we can actually do this. XY. So MN. So those who have joined late, I will remind you that we are using translation. And what is the meaning of translation? Translation is a parallel shift. You are pushing an object to a new position. Simply speaking, that's translation. But what is it that you have to tell me? You have to tell me what direction you are pushing, number one, and by what distance you are pushing, number two. You have to tell me these two things. Okay, so Shoradip is saying push the point F, push the point F by that bridge amount. Okay, let's do that. So if this is the length of the bridge, wherever you do draw it is the same length because the banks are parallel. So Shoradip is saying push the point F by the bridge amount staying perpendicular to the bank of the river. So he gave me the distance, how much the point F should be moved. He also gave me the direction that is perpendicular to the bank of the river. Great. So we have a new position. Let's call that new position F prime. Okay. So we have a new position and the new position is F prime. What should we do next, Shoradip? Tell me.
now we should join H and F prime.
Let's join H and F prime. Excellent idea. Let's join H and F prime. Okay.
And in this case, there will be only one intersection.
Yeah, because the MN line has already
Yes.
sort of merged with XY. MN line has sort of merged with XY. So there is no there is no intersection. So let me draw HF prime one more time. Let me draw HF prime one more time. So M has sort of floated to X and N has floated to Y, and we have this situation. Okay, excellent. We are almost done with the problem. What should we do next?
So we should expand the Mn back to where it was. Yeah, so we can label that point A and then draw a perpendicular line from A to perpendicularly down to Mn.
Excellent, very good. So pull the line Mn back to its original position. Just forget about all this HF prime line. Just mark A. Keep the marking. Bring Mn back to its original position. So this point sort of stretches up to here. F prime has floated back to F. F prime has floated back to F. So you have, this is the path. Okay. Excellent work, Shaurodeep and others who have contributed to the solution. This is precisely how Maths Olympiad level problems should be discussed. Now the question is, we have to test it, whether this is indeed the solution. We like it, it's kind of nice, but we have to test whether this actually works. So how do we test it? Well, we have to check if another line, another path is actually longer. So let's make another path. Let's make another path. Let's take this one right here. Yeah, let's take another arbitrary bridge, A prime, B prime. Let's join HA prime and B prime F. So we want to show that this is a longer path. The one that we just created is a longer path than the one that Shaurodeep and his friends constructed. So how do we show that HA prime B prime F is shorter, it's longer than HA B F? How do we show this?
So this is Arab. So you again put Mn back to xy, and you bring F up perpendicularly up the distance of the two river banks, and then you will get a slanted line while this is a straight line. So this is a triangle's property that the two smaller sides sum is more than the longest side.
Excellent. Very nice. Very good, Arav. Exactly, that's what we should do. Let's do the translation one more time. If we take F back to F prime, the picture becomes like this. H A prime, F prime is here. We know that this is a straight line. We know that this is a straight line, and this will come here. So now look at this particular object. This is a triangle, right? And HA prime plus A prime F prime is greater than HF prime, because HF prime is a straight line, and straight line is the shortest path from one point to another point. So it's very simple in that sense. Excellent work, Arav. And all of you can see that this notion of translation can be strikingly simple and yet very, very useful and powerful to solve beautiful problems. If you are in a geometry module and if you are at Chinta, then probably you are already solving some of these type of problems. If not, you can go and check Yaglom's book on geometric transformation. It's a very beautiful book. You can look into geometric transformations by other people like Vasiliev and so on. It's also this class will be also available in YouTube, so you can go to our YouTube channel and sort of keep an eye on that. The next session is coming up at 8 p.m. I will see you then, the people who are in the senior group. Till then, I'll see you next week for the next training camp. And if you are in a Chinta program, then I'll see you shortly in some other class maybe. Till then, keep solving great mathematics, and goodbye to all of you.